Okay, hello everyone. This is the second and final part of my video on finding the equation of the tangents with a given implicit function where we have a given x value. Remember, if you haven't watched the first part, go ahead and watch it so you know what we're actually doing in the second part. So in the first part, we found the derivative, the dy over dx, from our implicit function. And we also worked out what our y values must be for our points, because there are two y values to one x value, the x being the negative 1. So now we're going to solve and work out the equation of the tangents. So what we're going to do is we're going to take our derivative function, and then we're going to plug in the values of this point here first, because this one's going to probably be the easier of the two, just by looking at it. So, let's go ahead and do that. So we take our dy over dx, and it's negative 3 lots of x squared. So we put in our x from this point, which is negative 1 squared, and then it's plus 3y. So we have 3, and then our y value is 1. Again, just plugging in our x and y values. And then we have 2 lots of y being 1. Then it's take 3 lots of x, and x is negative 1 here. Okay, so let's go through this process. Negative 3 times by negative 1 squared. Well, negative 1 times by negative 1 is going to be 1, because double negatives make a positive. So that's positive 1 times negative 3. Positive 1 times negative 3 is going to be negative 3. And then plus, and 3 times 1, very easy, 3. And that's over. We have 2 there, because 2 times 1 is 2. And then we have take negative 3, because 3 times by negative 1 makes that. So we're going to have 3 times by that. So it's take negative 3. Double negative becomes a positive. So that's 2 plus 3 in the end. Now what we can do is we can simplify this, and negative 3 plus 3 is 0, and 2 plus 3 is 5. And we can simplify it down to 0, because 0 divided by 5 is 0. So now what we do is we put it into our slope form, so that we have y and x on either side of the divisor bar there, and we subtract the coordinate. So in this case, this is positive 1, so we take 1, because we're subtracting positive 1. Now x is negative 1, so we subtract negative 1, and we have 2 negatives, so that makes positive. And that equals 0. So now we just solve for y, and then we'll have the equation of our first tangent when x equals negative 1 and y equals 1. So what we do is we move this term here, and I might use a different colour just to help you out. But we move our x plus 1 up to there. I'm not even going to bother writing it out properly, because 0 times by anything is just going to be 0. So now we end up with y take 1 equals 0. Therefore, y equals, and negative 1, move it to the right hand side, we inverse the operation, y equals 1. And we have our first equation of a tangent. When x equals negative 1. So there's our first one done. That's our point negative 1, 1, so I can tick that off now. And then we repeat the same process for our second point, negative 1, negative 4. So we substitute it into the derivative equation that we worked out before. So dy over dx, so we have negative 3x squared. So negative 3 lots of x in this case is going to still be negative 1. So that's negative 1 squared. And then we add 3y. So it's plus 3, and in this case, y is negative 4. And now we do the bottom line, so 2y. Well, y in this case is negative 4, so it's 2 lots of negative 4. And then what we have is take 3x. So that's take 3 lots of, and x is -1. So now we simply simplify this down. So that equals, and 3 times by -1 squared. Well, that -1 times by -1 is going to be +1, and that's -3 there. So +1 times by 1, +1 times by -3, sorry, is going to be -3. So -3 from that. And then we add -12, because 3 times by -4 is -12, so it's just going to be take 12. Nice and simple. Bottom line, we have 2 times by -4, that's going to be -8, and then it's subtract -3. So subtract -3, because 3 times -1 is -3, double negative makes a positive. And then that simplifies down, because -3 take 12 is going to be -15, and -8 plus 3 is going to be -5. And get rid of the negative signs, because a negative divided by a negative is going to make a positive, and 15 divided by 5 is going to equal 3. Excellent. So now what we do again we put it into this slope form. So we have y, take our y coordinate, which is -4, so it's going to be y plus 4 in this case. And then it's going to be x, take our x coordinate, which is going to be -1 in this case, so it's x plus 1. And then that equals 3. Okay, so if that's the case, what we do is, again, like we did last time, we want to bring the denominator of the left-hand side into the numerator on the right-hand side. So what we get there is we get 3 bracket x plus 1, and then we can solve this down again to be 3x, because we're expanding. 3 times by x is x, and 3 times by 1 is 3, to be 3x plus 3. Then what we do is we write y plus 4, and hopefully you can still see it, but almost gone off the camera there. We have y plus 4 equals 3x plus 3, so then we just bring the 4 on the left-hand side over to the right-hand side, so therefore y equals, and if that's +4 there, it's going to be -4 there, so 3 take 4 is going to be -1, so we get 3x take 1. And that is the equation of the tangent, for our second y value, where y equals -4. Hopefully you've been able to follow this. Reasonably simple. Again, probably one of the trickiest parts of this is making sure you get the negatives and positives around the right way, and just also double check you remember how to differentiate implicit functions as well. So this has been a quick video. Hopefully you've been able to follow it. I will have more videos coming out, but again, this is the steps you follow. Remember to see part 1 if you haven't already, just to make a bit more sense of this and how we get these values up here. But thank you very much for watching, and I'll see you next time.